All right, this is day 2 of permutations and combinations. So this should be a review. A combination is a grouping of items in which order does not matter. There are generally fewer ways to select items when order does not matter. So here's an example. There are 6 ways to order 3 items, but they're all the same combination. So as a permutation in the blue, if you were to rearrange the letters A, B, C, you would get 6 permutations. But as a combination, once you've chosen A, B, and C, it doesn't matter the order. It's going to be only one combination. So when deciding to use permutations or combinations, you want to first make sure you decide whether order is important. Use permutation if order matters, and a combination if order does not matter. And then there are the formulas that were in our previous video. So here's example 2. There are 12 different colored cubes in a bag. How many different ways can Randall draw a set of 4 cubes from the bag? So in this case, this is a combination. Because the order does not matter. You are choosing 4 cubes from the bag of 12. So we'd use our formula NCR. So we start with 12 colored cubes and we choose 4 at a time. So we sub it into our formula. So 12 factorial divided by 4 factorial, and then 12 minus 4 factorial. Then we simplify. 12 factorial divided by 4 factorial times 8 factorial. And then I'm going to start to expand that 12 factorial in the numerator. So 12 times 11 times 10 times 9. And then I'm going to stop at 8 factorial because I have an 8 in the denominator. And then I'll expand the 4 factorial. So 4 times 3 times 2 times 1. And I'm going to leave the 8 factorial. Now I can just go ahead and cancel the common factor of 8 factorial in the numerator and the denominator. Then we'll multiply the numerator. 12 times 11 times 10 times 9 is 11,880. In the denominator, 4 times 3 times 2 times 1 is 24. And we divide those two numbers, and we get 495. So there are 495 different ways that Randall can draw a set of 4 cubes from a bag of 12. Example 3. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? So there are 8 total. So that's your N. And you're going to have groups of 2. And that's your R. This one again is a combination because you're having groups of 2 people. Doesn't matter the order in which you select the people. We're going to go ahead and write our formula, NCR. So we have 8, and we're choosing 2 people in the group. And we substitute in our formula, so 8 factorial divided by 2 factorial, and then 8 minus 2 factorial. We'll simplify. So in the denominator, 8 minus 2 factorial is 6 factorial. Then we'll start to expand. 8 times 7, and then I'm going to stop at 6 factorial. In the denominator, expand 2 factorials 2 times 1, and then I'm going to leave that 6 factorial. Now we can cancel the common factor in the numerator and denominator, which is 6 factorial and 6 factorial. We multiply the numerator. 8 times 7 is 56. 2 times 1 is 2. And then we simplify. 56 divided by 2 is our 28. Example 4. Katie is going to adopt kittens from a litter of 11. How many ways can she choose a group of 3 kittens? Again, the order does not matter. She's choosing them. So a lot of times when you see the word choose, think of that as a combination. So we have 11, which is our N, and we're choosing groups of 3. That's our R. So it's 11 combination 3. Substitute in our formula, 11 factorial, 3 factorial, 11 minus 3 factorial is 8 factorial. And then we start to simplify. So expand 11 times 10 times 9, and then stop at 8 factorial. Expand 3 factorial as 3 times 2 times 1. And then we'll leave that 8 factorial in the denominator. Now our 8 factorials will cancel. And then multiply. 11 times 10 times 9 is 990. 3 times 2 times 1 is 6. And then simplify that fraction and you get 165. We can have 165 different groups. Example 5. A security code consists of 5 digits. The digits are anywhere from 0 to 9. And a digit may not be used more than once. How many possible security codes are there? This is a permutation where the order matters in which you select. This is a permutation. So we have 5 digits. So that is our R. And then we have a total to start off with is 10. It's a permutation where order does matter when you're selecting your digits. So NPR So we have 10 digits, and we're going to choose 5. Now notice again, you cannot use more than one. So once one has been selected, it decreases. So we substitute into our formula for permutation. So it's 10 factorial over 10 minus 5 factorial. So we have 10 factorial divided by 5 factorial. So 10, 9, 8, 7, 6, 5 factorial, I'm stopping. And then I have a 5 factorial in the denominator. So those cancel. And then we multiply. And we get 30,240. If you like the fundamental counting principle instead, you would say how many choices do you have for the first digit? You have 10. Then that digit has been chosen, So now how many choices do you have left for the second digit? You have 9. Now that digit has been chosen, it cannot be used again. So now you have 8 choices left. That digit has been chosen. Now you have 7 choices left for that digit. And then in the last one, you have 6 choices. So that's the fundamental counting principle if you'd like to do that instead. And then you would just multiply, and you will get the same number, 30,240.